Hello class, this is Math 1430 Final Exam Review. I just want to go over one problem. Here it is. Find the equation of the tangent line to the graph of the function f of x equals x times the natural log of x at x equals 1. So here's the whole problem. You might want to pause your video and just read everything I wrote at some point, either now or later. Okay, so let me step you through the solution. So to find the equation of any line, you're going to need a point, x comma y, and a slope. We're given only the x value of the point, x equals 1. So let me show you what I'm talking about. So right here in the problem, we're told that x equals 1. We want to know what the y-coordinate of the point on that tangent line is. So if you're given x equals 1, go to your original function. Go to your original function and plug in 1. So f of 1 is going to be 1 times the natural log of 1. So let me continue where we are here. So in our solution, we're given only the x value of the point, x equals 1. So plug x equals 1 into the original function because we want to know what is that point xy on the graph of f, the original function. So when you plug in 1, you're going to output your y once you simplify. So here we are. We're told that f of x is x times the natural log of x. So when I plug in 1, I get f of 1 equals 1 times the natural log of 1. But the natural log of 1 is 0. So let's write 1 times 0 is what that simplifies to, which of course is 0. So when I input 1 for x, I output 0 for y. So this is the point x comma y, which is on the graph of f and where the tangent line goes through. So we know a point on the tangent line. Now we need to know the slope of the tangent line. So that way I can write the equation of the line, because once you know a point and a slope, you can write the equation of the line. So here we go. To find the slope of the tangent line, you must find the derivative f prime of x. F prime of x gives you slopes of tangent lines for any x. And then once we get that derivative, we want to evaluate at x equals 1, because when I evaluate the derivative of f prime of x at x equals 1, that will tell me the slope of the tangent line at x equals 1, which is what we want. Okay, so I need the product rule to find the derivative, because notice right here, f of x is equal to a product. This is x times the natural log of x. So to find the derivative function, we use the product rule. So it's the way I do it is the first times the derivative of the second. So there's my x times the derivative of the natural log of x is just 1 over x, plus the second, which is ln of x, times the derivative of the first. Well, the derivative of x is just 1. So that's what I wrote here. And don't the x's cancel here? So this is just going to be 1 plus, and then ln of x times 1 is just ln of x. So there we have it, 1 plus the ln of x. That's my derivative function for any x, which will tell me the slope of the tangent line for any x. But now what we want to do is evaluate this derivative at 1. So wherever you see an x, we're going to write 1. So f prime of 1, that means the slope of the tangent line at x equals 1. Wherever you see x's, you write 1s. So it's going to be 1 times, let's go to the simplified derivative. So f prime of 1 is going to simply be 1 plus ln of 1. So there we have it. F prime of 1 equals 1 plus the ln of 1. But what is the ln, or natural log of 1? It's 0. So this becomes 1 plus 0, which equals 1. So this 1 is the slope of the tangent line at the point 1 comma 0. Okay, so now that we have a point and a slope, we're ready to write the equation. So next, let's write the equation of this tangent line. And to write the equation of the tangent line is up to you. You can either use y equals mx plus b form, otherwise known as slope-intercept form, or you can use the point-slope form, y minus y1 equals m times x minus x sub 1. So whichever you're more comfortable with. So I'm going to do it the slope-intercept form way, because that's what it seems most people do. but it doesn't matter. Either way works. So to write the equation of the tangent line, let's begin by writing the slope-intercept form if you prefer that style. Y equals mx plus b. And we can plug in for y, m, and x. And that way we can find b. So remember, our point was 1, 0. So this 1 is your x and the 0 is your y, right? All points are x comma y. So wherever I see an x, I'm going to write 1. Wherever I see a y, I will write 0. So here we go. The equation of the tangent line. Instead of writing y equals mx plus b, for y we're going to write 0. For m, the slope, we're going to write 1 because that's what we found the slope to be. X is also 1, and then plus b. So just solve for b. Well, this becomes 0 equals 1 plus b. Subtract 1 to each side, and you get b equals -1, or -1 equals b. Now that I have b solved for, we're 99% done. And your final answer for the equation of the tangent line, keep x as x and y as y, but just plug in for m and b. So m, the slope, is 1, and b is a -1. So this looks like y equals mx plus b, but because b is negative, plus a negative is just a minus. And then, of course, 1 times x is just x. So this is the preferable answer, y equals x minus 1. And we're done. That is the equation of the tangent line. Okay, good luck, everyone. Bye-bye.